Okay, so today we are going to learn about two simple things. Let me say that again. We're going to learn about two things. They're not necessarily simple. However, they are very, very important. So on a couple of the problems that we saw in the homework yesterday, you were presented with a product and you were asked to find the derivative of that product. We learned two things. Number one, you can't do that. And number two, in order to be able to do that, you have to multiply it out. That will eventually become a major pain in the butt. So we're going to come up with some different ways to do that, and that gives us the product rule and the quotient rule. Okay, but first, let's practice. Go ahead and solve that.
Does that happen if I open the PDF? Or the
Having fun? Panicking?
Emma, you get the first term. What's the derivative?
20x.
I just broke my board. Let's try that again. I'm sorry, 20x what?
Cubed.
Cubed. Beautiful. Shane, how about the second term?
1 over 18x to the 7th.
Positive or negative? Is it plus or minus?
Positive.
Correct. Okay, it is plus, but you made a mistake. What's the mistake? Right, the 18 doesn't go into the denominator. So when you bring the negative 6 down and multiply it by the negative 3, you get 18x to the negative 7. It's only the x that moves to the denominator. So just to make our lives a little bit easier at this stage, we'll leave it as 18x to the negative 7th. Matthew, last term.
Positive 6x to the negative 1 half.
Positive 6x to the negative 1/2. Perfect. Problems? Okay, good. The only one you really need to worry about rewriting is the square root of x, which you all know is x to the 1/2. And then just make sure that you're subtracting 1, because negative 6 minus 1 is negative 7. Hot diggity. Okay, so, what's the matter?
How come we simplified the 18 over x to the 7th, but we're keeping that one like that? Is it?
Probably should have, but
Okay.
I don't really care. Again,
Okay.
if you can get that, I'm happy.
Okay.
We'll worry about the negative exponents later. As I mentioned, we're going to talk about product rule. We're going to talk about quotient rule. That's the meat and potatoes of the lesson today. We're also going to learn about the other 4 trig functions. We haven't talked about the derivative of tangent, secant, cosecant, and cotangent. Those will come along. And then, of course, we're going to talk about a higher order function. We've hinted at that already. Everything we've done has been a first derivative, but as I was talking about with the degrees, you can take the derivative of a derivative. You could take the derivative of a derivative of a derivative. You could take the derivative a lot of times. Those are called higher order derivatives, something more than one. And then of course you should try to eat more vegetables. None at all? You've just drawn the line in the sand. No veggies for me. Okay. We'll see what
I am
happens.
the exact opposite of you.
Okay, so the product rule. Now, it is possible that you could get through calculus by never learning the product rule. It's not what I would recommend at all. Because if I get something like this, you're all fairly bright. At this point in time, without the product rule, you could take the derivative of that function, could you not? Luke, you started this mess earlier. How would you find the derivative of that puppy?
I just distribute.
Yeah. Foil that bad boy out, get a function, take the derivative. I did that work for you. So again, just be mathematical sponges and absorb. That's all algebra. simplified it down to h of x, and then I took the derivative. Notice my notation. There's no confusion about what's going on there. The second term is still h of x. The third term is still h of x. And then all of a sudden the derivative magically appears. Okay? Problems? Beautiful. I would not recommend doing that, and because of that, I'm going to show you what the product rule is. The product rule will allow us to take the derivative of two terms multiplied together, just like we have here. Okay? So here's how it works. You'll notice it's a product of two things, one labeled in red and one labeled in blue. In order to take the derivative, you follow a little bit of a pattern here. And that pattern I'll illustrate in the next couple slides. Just watch first. Okay. H prime of x, labeling what I'm doing here. The first, okay. By that I mean all I did is just copy down the first term in red. Times the derivative of the second. What's the derivative of 5 plus 4x, Em?
4.
Not very exciting, but true. Plus the derivative of the first. M?
3 minus 4x.
Times the second. All done. Let me say that again. Actually, I'll click so that you can see it while I'm reading it to you. The first times the derivative of the second plus the second times the derivative of the first. Now, the stuff I have in red is pretty much mentioned up inside the box, but for some reason when people see the word moreover, they start freaking out and just ignore it. So I thought I'd write it out again for you. This is also important. First times the derivative of the second plus the second times the derivative of the first. Now, some of you might get all fancies in your pansies and might decide, oh, you think so? I'm going to do the derivative of the first times the second plus the first times the derivative of the second. I'll show you. That's fine. It's a plus sign. Who cares? 1 plus 2 is 2 plus 1. You'll show me. Problems, questions? By the way, just for information purposes, how many of you are taking notes on the actual slideshow? Okay, just checking. I have mentioned that I make the slideshows available so you can take notes on the slideshow. If you're going to do that, I post two versions. One is the PowerPoint, PPT, or PPPX, or whatever it is, or a PDF. The PDF works better, right? Did that work out for you?
Yeah.
The PDF works better?
Yeah, it works
Okay.
better. 'Cause there's like missing parts on that.
Yeah, because, yeah, I like to get all fancy.
Yeah, like fill it in.
Yeah. Okay. All right, do that one. Now, notice it says using the product rule. I know you know how to multiply out two binomials, but I want to see you use the product rule. All right, Dexter, your turn. What do you got for me?
As in what?
It's up to you. You want to just give me a final answer, or you want to go step by step?
I can do step by step.
All right, I'll get you started. I'm feeling generous. There you go.
Equals 3x squared plus 7 is what they did first. And then I got the, the next one is just 1 because it's like the derivative of x plus 3 is 1. And then x plus 3, and then x cubed plus 7x.
What goes here?
Plus.
Okay. What did you do wrong?
Is this the last one supposed to be the derivative?
But
I'm pretty sure you don't have to take the derivative of, for example, in the first value, obviously 1 is the derivative of x plus, well maybe not obviously, but 1 is the derivative of x plus 3, but for the first term you just want to keep that the same, and so the same goes for the second.
Your parts are all there. Your parts are in the wrong places. That just didn't sound right, did it? Let's just move forward. Okay. So you've got this f prime here. You've got your g prime here. Plus your gx and your f of x. You just have them in the wrong spots. Okay, so how do we fix that?
swap them over.
I'm just going to erase. Start over.
Erase all of it.
Yeah, I know.
3x squared plus 7.
Well, we can go that route if you'd like. I mean, if you want to get all fancies in your pantsies, you can do that. That's a derivative of the sorry, the derivative of the first times.
Times x plus 3.
Okay, good.
And,
Plus
1 times x cubed plus 7x.
again, all your parts are there. We're good to go. That's correct. Okay. Now that may freak some of you out because if you follow the rules exactly, it would be x cubed plus 7x times x plus 3 plus, what am I doing? I lost track of what I was doing. Sorry, x plus 3 times 3x squared plus 7. Okay, it doesn't matter, that's fine. Okay, question?
Is that just your final answer?
For now, if you, again, we're taking baby steps, so if you can get to that, great.
Oh.
Later on, you're going to find that dreaded word. What's the dreaded word? Simplify,
Okay.
where you're going to multiply this bad boy out.
What's the
Okay, that's
answer?
what I thought.
What's the answer?
What's the final answer?
Yeah.
Oh, I don't know. I didn't multiply. Do you want me to multiply it out? What am I?
Yes.
Like I'm a performing circus chimp or something?
I did,
Yes,
and I just want to know if
exactly.
it's right.
I don't know. Hey, just for giggles, I'm avoiding answering Molly's question or doing what she's trying to make me do. What degree is that equation?
When you simplify it?
No, just g of x. What degree is g of x?
Oh, 4.
It would be a fourth, correct, okay. So theoretically, after I've multiplied this whole monster out, it should be a degree 3. I don't final answer. Don't even have it. Did anybody multiply this out?
I did.
Oh, all right, share. What do you got?
4x cubed plus 9x squared plus 14x plus 21.
Okay, great.
Who's in law?
Good.
So
Questions?
it must be.
So again, depending on how you want to operate, you can put those together in a variety of ways, but there are also a variety of ways that you can do it wrong. But it's always the combination of the derivative of one times the other one plus the derivative of the other one plus the first. Okay? Quotient rule. This one's a little scary. Now, the reason this one is a little scary is because when we did the product rule, we know that a plus b is the same thing as, b plus a. Correct?
Yes.
Good. However, A minus B is not the same thing as B minus A.
Very good.
Good. I know this is like very basic algebra, but I'm trying to make sure we don't make the same mistakes that I've seen for 20 years now. Yeah. So, here we go. There's the quotient rule. It looks very scary. But I'm going to talk you through the internal talk that I use when I'm solving a quotient rule problem. That red stuff at the bottom is not necessarily the way I do it, but I'll let you write that down if you'd like. I'll show you how I talk myself through it when I do the problems, because it's very easy to screw up. And please be sure to copy that down correctly, because order is important. Not like the last one. And this is just some craziness, obviously. God. Okay, we ready?
No.
Hold on.
No.
Excited.
If this is like the,
I hate quotient.
what was it? What was the little slogan?
Oh God.
I can't even, I don't want to even think about it.
Cody has
No.
no.
Oh no, I don't want to know.
Over. Ho or something
From
like
Hernandez?
that. Yes.
Hody
It was so
hee,
bad.
hadi, hoda hodi, hada hada.
hated it
Hoda
so
hee,
much.
ho
She's so
ho
nice
yaha.
I couldn't understand it. She could just keep saying it to me.
Every time I teach quotient rules, some knucklehead fires off the hodi hee, hada hoda.
So bad.
Hosa hada hoda. Yeah.
Oh,
Let's agree to never speak of that again.
I didn't do that.
didn't.
I'm so good with
Do you guys actually know what it is?
Yeah.
What is it?
It's Hody High or Heidi Ho.
No.
Yeah.
Oh, he's-
Yes,
oh,
it is. Yes, it is.
Hody
Yes,
high
it
minus
is.
Heidi
No.
ho over ho ho. Yes.
Yeah.
All right, let's do this. Okay, now, unfortunately with the quotient rule, with what we know now, there's no other way to take the derivative of this thing, because you're missing another derivative component that we'll get to later called the chain rule. The product rule problems, you can always multiply out a product rule and just take the derivative of that. For this puppy, here's how I do it. You don't have to do it this way. It's just worked for me for a number of years. I start with a big gazinta bar. Okay?
It's okay. I'll find it somewhere else.
I take the denominator, leave the denominator in the bottom, and square it. I take that original denominator and bring it up to the top of the gazinta bar. Put it in parentheses.
Why are we calling it that?
It's a gazinta bar.
What does that mean?
How many have never heard the term gazinta bar before? Are you kidding me? You know Heidi Hoda Heidi Hada Ha, but you don't know a gazinta bar?
Yeah.
No idea.
Last year
What
was
is
kind of
it?
messed up for me.
3 gazinta 2?
What?
No.
Oh, I get it.
Ew, wait, I hate that.
Stupid.
That's actually
I don't.
Thank you,
That
Matthew.
sounds like a movie.
Oh.
It's a division problem.
Second.
Three gazinta 2.
I've never heard that before. I don't think I
That doesn't happen in my mind.
Kids these days. Okay, so denominator in the bottom, square it. Leave it alone. Bring that denominator up to the top of the gazinta bar. Now I need to marriage that denominator with the derivative of the numerator. 5. Beautiful. Minus. Since I brought the denominator in first, now I have to bring the numerator in. Times the derivative of the denominator. Okay, now to make your life a little bit easier, we're going to go back a slide, and I'm going to have you do this. Big honking bracket around that mess. That will help eliminate some of your sign errors. Now, if you're feeling saucy, done. Now, I would like to be positive about this and say don't make mistakes. However, I'm going to be negative and point out there are a lot of places to make mistakes in the quotient rule. Putting the wrong thing on the bottom, using the wrong form in the numerator. If you want to just memorize this, okay, but I'm not a big fan of memorizing. However, the method that I use to solve that is pretty much memorization. Denominator in the bottom squared, bring the denominator up to the top times the derivative of the numerator minus a big honking bracket, the numerator times the derivative of the denominator. Whoosh. Always simplify numerators. Do not simplify denominators. That's particularly important in the future when we start doing some craziness. Until that craziness comes along, well, not until, just don't simplify denominators. Leave them alone. Questions? Practice, practice, and then a little bit more practice will help with this. Go ahead, practice. How are we doing for time?
20 minutes left.
I'm sorry, I might not give you a break today because I want to try to get through this slideshow. Are you going to be okay with that? Okay.
Persevere.
We'll live, but we're going to be scarred for life.
We'll live, but it won't be great.
I don't like the fact that I flipped my paper and now I can't see it.
Oh,
Sorry, Ellen.
the derivative of 9 is 0. It's 0. It's 0. Yeah.
I would just like sit. That is the worst.
Remember when you would like stress out and me and Kenzo would be laughing at how much we
Just sit there and close. I would go mad at them. It's okay.
Okay, let's move along. Hafiz, you're up. What do we got?
Alright, so on the bottom, we got 3x squared minus 2x, and all that squared. And then at the top, we have 3x squared plus 2x, and then we have 0,
I assume you mean that, right?
and parentheses.
Yeah.
Yep. And then minus 9,
Big honking bracket.
yep,
Yep.
9, and then 6x minus 2.
Close big honking bracket. Agree or disagree?
Yes.
We got a thumbs up from Mr. Zimmer. We're good to go. However, we can continue with this. Can we not, Hafiz?
Yeah.
What would I do next?
Simplify the numerator.
Yeah. And again, it doesn't require rocket science to realize that's going to go to 0. And I get negative 54x plus 18 over 3x squared minus 2x quantity squared. Yes. Am I done?
Yeah.
Yes. But 18 times 3 is 54, so you could factor out a GCF. We're not going to. That comes later. But you could have. It really won't do anything for us except showing off. So we'll just leave it like that.
That sounds good to me.
Okay, think you can handle that?
Yes.
As I mentioned 2 minutes ago, practice, practice, practice. Good. Yes?
Yes.
We don't need that, do we?
No.
Okay, good. Let's see. There's the answer in case you're wondering. Okay, in case you were that fast. Let's do this instead.
Can
Woohoo!
we go back a slide?
So we've taken the derivative of the sine function. Well, we haven't. I just told you what it was. And you learned the derivative of the cosine function. We did not talk about the other 4 trig functions. Like, for instance, let's start with tangent. Does anybody have, I don't know why you would know this, but I'll throw it out there. Does anybody know the derivative of tangent?
No.
No? No, no, no. Any ideas how we could find the derivative of the tangent? I do.
Treat it like a quotient.
Wait a second.
Hot diggity. Tangent of x is equal to the sine of x over the cosine of x. Oh, look, it's a what did you say?
Quotient.
Wow, I don't know what just happened there. Yes, it's a quotient rule. And we know how to handle quotient rules now. So we can just go crazy on this bad boy. For me, I'm just going to click. I'm doing the hard work. Notice the notation. Okay, d over dx. The derivative of the tangent of x with respect to the variable x is the fancy way to say that. Wha-bam! Oh. Oh. What is going on? Okay, so I threw an extra step in there because I wasn't sure if you were going to be able to handle the quotient rule, but obviously you did a lot better than I expected. Good job. So I wrote the whole thing out. What is this? The numerator or denominator squared on the bottom, bring the denominator up to the top, times the derivative of the numerator minus big honking bracket. It's a big honking parentheses, but bear with me. The numerator times the derivative of the denominator. Gazinta. Okay? Not Gazinga. That's something completely different.
Oh, sorry.
Then I got all fancies in my fancies. The derivative of the sine is the cosine. Cosine times cosine is cosine squared. What's cosine squared plus sine squared? 1. It's probably the only trig identity you remember from pre-calc. 1 over cosine squared is secant squared. We could do that with all the other 4. I could click my brains out through the other 3, I should say. I'm going to spare you that difficulty and say, there they are.
Yeah.
Each one of those would be done the exact same way we did it. It isn't a fluke that I gave you that problem with a constant in the numerator. Why did I do that? Because number 1, it's good practice, but number 2, it would also help you do the secant, for instance. Secant is 1 over cosine. Use the quotient rule. Cosecant is 1 over sine. Use the quotient rule. Have I used the term note card worthy yet?
Yes.
Okay, these are note card worthy. Could you conceivably sit down at a test and have to take the derivative of secant and derive that and get secant tangent? Yeah, but you're not going to have the time. So at some point through practice and through memorization, and again, I'm not a big fan of that, but you'll make that part of your psyche and be able to find the derivatives of those 6 trig functions. Are we good?
Yes.
Good. Almost done. Higher order derivatives. Easy peasy. If you can take a derivative now, you can take the derivative of a derivative later. But what I wanted to show you was this monster. I'm sorry about this. Well, bam. Yeah. So let me talk about this. Later on, in an upcoming slideshow, I have a little history lesson for you. But until we get to that, let me explain some of this different notation. different people worked on calculus at the same and different points in time. And for some reason, each one that worked on calculus decided, oh wait, I don't like that knucklehead's notation. I'm creating my own. And it creates this mess that you see on the board. So sometimes, like in Algebra 1, you would refer to a function as y. And then, when you started taking higher level courses, you were big people and we didn't use y anymore. Y's became f of x's. That's where the first two come from. And then when you take the derivative, it becomes y prime, f prime, y double prime, f double prime, y triple prime, f, etc., etc. At some point, the dashes become numbers. I cannot think of a single instance when we would do the fourth derivative of anything, let alone the nth derivative. Okay. I've talked a little bit about this, the derivative of y with respect to the variable x, dy dx.
Phone ringing.
Hello? Hi. The extended warranty. Haven't seen it yet. Yes? Well, thank you. Please close it out. No. I put you on the do not call list. Who's number 12?
That's me.
Yeah, you're on the do not call list now.
Thank you.
Did you want to, maybe I overstepped my bounds, I'm sorry. Did you want to re-up your coverage on your vehicle?
Was it a scam likely?
It was, but I mean, it could have been legit. Maybe he actually had a policy for your car that your maintenance.
Eric thinks it's legit.
No? I'm sorry,
No, it's fine.
we're good? Okay, good. So then, if we know what the function is, then dy dx can become d f of x dx. Okay, the derivative of the function with respect to x. And then occasionally, this capital D thing pops up. Yeah, I don't, but just so you know, if I never talked about it, the very first question on the AP test would be that. And you'd be like, what? But now that I've shown it to you, I'm off the hook and it's on you. Okay? We're done.
That's actually true. That's a really good point.
It's funny.
Okay, so.
End of your lessons, like, take digs at math. Like, it's kind of fun.
Yeah, well, I mean, math's kind of dumb.